All right, so for number 3, this question is on 10.2. It's area between curves. It says this one: sketch the region bounded by the given curves and find the area of the region. So with number C, letter C, right away you see that the tricky part about this is that we have a y squared there. Well, what's a y squared doing there? We've never seen that before. It's true. Now this could easily be changed into this: y equals the plus or minus square root of 2x plus 6. So that's one way to look at this and say, okay, now I have a line and I have a positive and negative version of a root function, which you may or may not know, but when you have, a y squared, you could solve for x here, which will be one of the strategies that we could use for this. You could solve for x and then have x equals something y squared. And that would be basically an inverse of a function that we're used to, y equals, right? This right here, if you remember from pre-cal 30, we studied radical functions. We also studied transformations. So a rough sketch would put this to be looking like this: 2x plus 3, okay? And which means that we would have what? We would have 3 units. It would be shifted 3 units to the left, okay, and it would be squished up a little bit by 2. So this would be a regular sort of square root graph. Don't write this down, but this is the regular square root graph. Remember that? Okay, that's the positive version of a regular square root graph. So we're actually going to move this over to the left 3 units. So instead of at 1, we're going to go like this. Okay, just as a rough sketch. That's the positive version. And the negative version is like this. Now that looks like a sideways parabola, doesn't it? Because it's really an inverse of, if you switch the variables around, you would have a parabola that, that opens up and looks kind of like this. Okay? So it looks a little weird. That's why we have the plus or the minus, because it's not a function when you consider it all at once. Okay? So you have the positive version here, and then you have the negative version, the positive arm and the negative arm. Now, with this line over here, y equals x minus 1, well, that's going to be, now negative 1, we could see what's happening at negative 1 where this is. So negative 1 plus 3 is 2. 2 times 2 is 4. Square root of 4 is 2. So negative 2. Here's negative 2. Here's negative 1. And then, so this line kind of goes like this. It's a line looks like this, right? So this makes this really tricky. And why does this make this tricky? Because if we're trying to find the area between each of these curves, or between these curves here, I'll just make this a little bit bigger and bring it down so we can see everything. Then we have multiple sections here, right? And so here's option 1. This is what makes this tricky. Option 1 is I want to find this area right here, this whole area, right? Everything in between here. Isn't that what this says? Is that correct? The area in between the curves. Sketch the region bounded by the given curves. So that's what I want to find. But I have to split that up into sections. So here's the first section. Now, why is this the first section? Because I have an upper bound and a lower bound that doesn't change throughout this interval, right? So this is the upper bound function, the lower bound function. That's these two right here. Then what do I have? Then I have, I just have 2 sections here, it looks like, right? Because now I have this second section, which has an upper bound there and then a lower bound of this line. So I have 2 sections that I would have to find the area of. Now, that's tricky part, step 1. And we've done questions like this before, right, where we've had to kind of split it up, like with that triangle question I showed you yesterday. Remember? So this is not beyond the reach of our imagination here. The second part of the trickiness is that I have to figure out what x value this is, the far left boundary, And I have to figure out what intersection point this is, right? That's my middle boundary line. And then I have to find out what intersection point this is. So I need to find out where my intervals are, from here to here, and then from this one to the end. So I have to find those points now, okay? So shouldn't be too difficult, I don't think. I'm going to let one of these radical square root functions here equal 0, I guess, right? So 0 equals root 2x plus 6, use whatever version you want. So how do I find out what x value gives me 0? Well, this needs to be 0, right? So I technically square both sides, and I get 0 equals 2x plus 6. So minus 6 equals 2x, x equals negative 3, looks like. So here's x equals negative 3. Is everybody okay with that? Getting that first part, determination? All right. So we've got that. Now I need to find the intersection point of this line and the negative version of this radical. Okay? So I need to find the intersection point here between y equals x plus 1. So I'm going to let x plus 1 equal negative 2x minus 6, you see? This is the negative arm of this radical, and this is the line here. Okay? Now this isn't to scale, this graph isn't to scale, could be 0, I don't know, it could be negative 1, could be a fraction. We're going to find out. So if I multiply everything by negative 1, I guess, I would have negative x minus 1 equals root 2x plus 6. If we do that, or if we just squared both sides, we could square both sides right from the beginning and get rid of that negative. Question?
Why is it x plus 1?
X minus 1, sorry. This should be x minus 1. Thank you. Yeah, x minus 1. So I could square both sides now. So this I can change this to 1 minus x. That's a bit more palatable. So I could square both sides, and what do I have? I have 1 minus 2x plus x squared equal 2x plus 6. And if I got everything over to the same side of the equation, what would I have? I'd have x squared minus 4x. I'd subtract 6 from this side, it'd be minus 5. And I would have here x, looks like negative 5 plus 1 equals 0. Negative 5 plus 1. So x equals positive 5 or negative 1. Is there anything that looks like it might be a possible solution according to our sketch here? Maybe a negative 1? Okay. The positive 5 is rejected. When we square things, sometimes the math gets a little funny. That's why we have to double check. Okay. All right. Okay, so sorry, as I just mentioned here, if you try the second one here, no, so y equals positive root 2x plus 6, and then let that equal to x minus 1, and you squared that, blah, 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 you would get x equals, you would get, I think you would get the exact same thing, actually, because 5 is the other intersection point here. So you get x equals 5 and negative 1, because squaring makes the positive really kind of go away, in a sense. So 5 is our other x value. Okay, let's keep going on here. We're getting, it's a long question here. So what do we want to do? Then we want to find our antiderivatives, which is the antiderivative of a radical going to be a little tricky? Yeah, maybe. That's why the second method that I'll briefly explain later might be a little bit easier, but it's tougher to think about it that way. But we want to go, what do we want to do? We want to do root 2x plus 3 minus a negative root 2x plus 3 plus 6 here without the brackets. So that's going to be this function minus this function, right? So this is our first one, h of x, which is going to be just 2. So now what's our antiderivative here? What's our antiderivative here? This is a positive 1/2, right? That's a positive 1/2. So you want to add 1 to this here to make that a 3/2, and then you want to divide by 3/2. So that's actually let's go. It's 2/3 times 2 is what dividing by 3/2 looks like. And you've got 2x plus 6 to the power of 3/2. And then, now who was I talking to the other day, Joy, about the, remember when we did this antiderivative, right? Was it you did you redo that question? About this and dividing by 2 here, right? Did that work when you divided by 4 with that other one?
I ended up doing this specific question in a different one.
So because we want to undo the chain rule, we have to divide or multiply by 1/2 here to get rid of the chain rule there. Okay? So that simplifies down to, let's see if we can do this here. So the 2's will go away there, and we have 2/3 times 2x plus 6 to the 3/2. So then what we want to do here is, this is going to be from -3 to, what did we say this was, -1 as an x value, right? So we are going to calculate the area here. So the area 1, is going to be this evaluated from -3 to -1. So that's going to be so having evaluated that, I get 38/3, and you guys got that too. So now we add area 1 and area 2, and that should be our area. So area total, area 1 plus area 2 is 16/3 plus 38/3, which is what, 54/3, which is 18 units squared. Oh, praise the Lord. That's what I got doing the other method. Okay, so that is that is finished. That is what, fill in the blank, a nightmare? No, that is lots of fun for a Saturday afternoon. That is now done. Okay, all right, so there was a lot of things we learned in that question. That's a great question to review everything that we've done so far, and that's a higher level question for sure. So the other method, which I said we were going to talk about, which I think we've spent enough time on this, the other method, just really briefly, is to take these original equations and solve for x and graph the inverse. Because what you're going to get is you're going to get something like this as an inverse of this line, and the inverse of this is going to be, something like this. So that you're going to get a parabola that opens upwards. So then you have you just have 2 intersection points, and you don't have to split this up into 2 areas with multiple sections. You can just do 1 section, but that is including the inverse. That's by graphing the inverses. Okay, so that might not be something. Again, you can check the solution document. We can talk about this another time. I'm not going to do this question again. We've spent enough time on it. But if you just flip everything, right, from going sideways like that parabola, really going sideways, flip it to a parabola going upwards. Yes, you do have x equals y squared and blah, blah, blah. But if you find the intersection points there, solve for x, intersection points, then you have just 2 boundaries, one there and one over here. Okay? So maybe a little less in the middle here to figure out 18 units squared, but that's a different way of looking at it. So might not be your first option, you know, to think about, let's sketch the inverses and find the area between those, because it would be the same area. So that's why I did it this way. This is probably the way you'd want to think about it. Okay? Any questions on that? All right.